Welcome to the second of this short series of COVID update webinars put on by the Royal College of Pathologists. My name's Will Irving and I'm chairing them. What I should have done last week, but will do now, is to thank Shelley Hurd from the Royal College, whose suggestion it was that we have this series of update meetings. And I can tell by the number of people registering that that was a very good idea. We had our first meeting last week when Andy Ustianowski gave a fantastic talk on current therapy for COVID. That was recorded. It should be available on the RCPath website if you missed it, or if you want to go and have a look at any details. It should be available before the end of this week. This is the second of the series of 5. It's on another critical issue, that of testing. Just for any newcomers, the format is that we have a guest speaker who will speak for 15 to 20 minutes, and then we'll have a 15 to 20 minute Q&A session. If you have any questions, please do type them out on the Q&A function, and the team at the Royal College will feed those questions through to me, and then I will pose them to our speaker at the end of his talk. This session will be recorded and should be available for people to have a look at early next week. I think that's all the housekeeping that I need to cover. So without further ado, it's a real pleasure to introduce a colleague, Sudhanva, who is a consultant clinical virologist at King's College Hospital in London. And more pertinently for this talk, is the lead clinical advisor to the Lighthouse laboratories and the consultant virologist to the particular Lighthouse lab at Milton Keynes. Sudhanva is going to talk about testing. He's got a lot of slides, but assures me that he's going to cover them all in the time available. So I will hand over to you, and the floor is yours.
Okay, so the title of my talk now is Testing for SARS-CoV-2 RNA, Bigly. So you know why Bigly has come about. So we are looking at history. So I'm going to show you what's happening in a big way. So to declare, I have no stocks and shares with any of the companies listed in my talk. So I'm going to go through this using 9 different learning points. The first question is, what pillar? I never knew pillars existed until about February, March, and maybe because the testing was in the basement at the time. And now pillars appeared. The pillars that are relevant to us are the Lighthouse labs, which is where I'm talking about primarily, and of course the pillar 1, which is the NHS PHE lab. I won't talk about the antibody and a little bit reference on the ONS who send samples to the Lighthouse labs. So as you can see, the capacity of the Lighthouse lab as of this week is about 614,000 samples, whereas that can be tested, whereas in pillar 1 is about 1/3 of it. So way back in April, as you can see, pillar 1, you had a lot more tests, 10,000, there's nothing at all in pillar 2, and that ramped up, and very soon, as you can see, 120,000 samples were being tested by August, and pillar 1 was around 60,000. Now that acceleration has happened, and our top line here is the capacity for testing in UK. As you can see, in September, there's a problem because people went to Italy and Spain and France and came back on holidays. And that led to an increased number of families trying to get testing. And now we have a lot more capacity, and then have got a spare capacity to test, and this is the capacity in UK is tremendous. So when the Lighthouse labs were created way back in March, the infrastructure did not exist. The Army, NHS Digital, NHSE, DHSE, PHE, Deloitte, veterinarians, universities, industries, they all came in to help to set up the lab. For example, the IT portals, the Army brought in equipment from the universities, reagents and equipment were brought in, and you had the staffing, which I'll talk about that later on. And the DHSE fast-tracked purchase. If you remember, at that time, we had a lot of swab shortages. There are a lot of validation we had to do, and also a lot of shortages of equipment. So to build a lab, we need construction. And this was a shell of a lab. This is the actual shell from Google Earth. As you can see, it's a square rectangular building. And that construction happened in March, April. To quote one of my colleagues who was there from Oxford University, Dr. Mike Hill, we had to build an airplane, and while building it, we had to fly it. And that was the pressure. Every SOP that we had a half-life of over 24 to 48 hours because things would change. So that is a construction then. And of course, in November 2020, we had to redo the reconstruction because of the extra equipment and extra technologies that we had to implement. So one of the equipments is CAS. What is CAS? CAS is contained air solution, which is a MSc class 2 cabinet. And the reason for that is within that, you can put in a TCAN machine. That way, all the pipetting from the primary sample can happen here. And that PC there will have the limbs within it so that we can record. And these are the TCANs which are ready to get installed within the CAS. So whole of the world supply basically ended up in Milton Keynes at that time. This is in November. And then you have the Kingfishers being unpacked and then installed. As you can see, we had to have power lines coming from above. And this is all done in a matter of few weeks in November, December. And of course, we have the two Nexars in the room. I'll come to that later on, why we had to build this specific room for the Nexars. So when the samples come in, you need to have the handling and the extraction. And this is the original marquee where the samples would come in from the lorries. And you can see these racks being stacked up there. And from there, they would come into this room where they would unpack it. And this whole layout has now changed. This was in April to November. And then they would put these things in these boxes. And the 550 grams was equal to about 93, 95 samples. And that's how they would put them in, and they would go through the hatch into the safety cabinet. And here you have the manual class 2 cabinet where you have a person who's pipetting, another one who's a caller, a witness. And using this, two of them, you are looking at 1,880 samples per day can be processed. This is on a 24-hour shift. This is manual. Whereas if you use the CAS and the TCAN, which I mentioned, showed you the photograph earlier, you're looking at 5,300 samples can be processed. So there's a substantial increase in capacity by using the CAS. So when you have the CAS, so you're going to do all this work. So ideally, the Kingfisher extracts should be right next to it. And that's how the laboratory was designed. So one Kingfisher can extract 4,464 samples per day. And these extracts are stored and sent away to Sanger Institute for sequencing, and which is one of the reasons why Sanger Institute has the world's largest contribution to the SARS-CoV-2 RNA sequences. So this is the place now in working. So we have the cabinets and Kingfisher extraction, as you can see, right next to each other. So now I'm going to talk to you briefly about PCR, real-time, and endpoint. I'm assuming everybody is aware of what a PCR is. I'm not going to the details of it. Straight on, the TACPath COVID-19 assay was one that was used, and we hit gold because straight away the assay started working very well. It's a multiplex of three genes for the SARS-CoV-2, the N gene, S gene, and the ORF1AB. And of course, the internal control was inhibition control was MS2. Fudge. So one ABI could process, ABI 7500 could process 1616 samples per day for PCR, real-time PCR, and we had 42 such machines with a capacity of 67,000 theoretically, but we didn't have enough number of CAS machines to actually open the samples. So some of the things we solved were design software were issued in March 2020. So very quickly we had the artificial intelligence / machine learning. And the Eugentech Fast Finder was a software that was used. We trained it, we fine-tuned it, and the results from that would go on to the Brooks Limphinity and on to the NPEX, which is a portal for the results to go out to the patients in the community. So in 2021, the HSE are tendering for the machine learning software. So this is the line, which is a real-time PCR, TCAN, Kingfisher, TCAN for PCR prep, ABI 7500, and Eugentech, and going back into the LIMS software. Whereas the new LGC endpoint PCR, the PCR prep, you would take a 96 well plate and then we rearray to 384, and that would go into the Nexar machine, more about it later on, and to the hydrocycler for heating and cooling, and to the Araya for detection, and the results will go, the raw data will go on to the Eugentech and then come back to the LIMS. So this is a thing, if you can see this is the actual tape, which is a Nexar flexible tape, which has a 5 microliter well, and that's my Lamy pen, where you can see that how small it is, and this is a 384 well plate. And this one, like a cassette player, will unspool this and it's pipettes, and then it's sealed up later on, and it can pipette up to 6250 pipetting actions per hour. And that's the next are nearly in operational. And then once the spools are ready, they go into the hydrocycler for heating and cooling, and that can process 12,000 samples in 50 minutes. So once it's done, it goes to the array for detection. It can process 9,600 samples, can be read in 1 hour. So we have 2 of such arrays in place. So to have all these things, you need to have a way to get the laboratory up and running. So for that, this is the national checklist where new laboratories are commissioned this way. I won't go into the details of these slides. These are official NHS test and trace slides. They have the laboratory validation and the quality assurance. And that's true for academic labs, private labs, Lighthouse labs, or the mega labs, which I'm going to talk about, mobile labs, pop-up neighborhood labs, and other type of anyone else who want to come into the program. So how does that happen, the validation process? You have the commissioning from the laboratory capacity team, then you have an initial meeting, and you look at the validation report based on audit documents, and then sign-off is completed, and quickly you start ramping up, and then any changes, you have a change control process. And when during the audit document, these are the key areas that are checked. You have the operational management. There's a big list there. I want to go into details. You have the internal quality controls. And of course, you have the pre-analytical, analytical, and post-analytical. I'm focusing mainly on the analytical side because that's where we have control over most of the within the laboratories. So because pre-analytical, we had something like 35 different types of combinations of swabs and tubes. And that's because there was a worldwide shortage of swabs and tubes way back in March, April, if so many of you may remember. So the assay that we had, we used a kinetic analytical linearity panel, which has about 8 dilutions, and the 9th one is actually a negative. And we set the pass mark at this particular thing between SO6 and 7, which amounts to 500 digital copies to 100, that transition. And in triplicate, 3 out of 3 should be positive, and beyond that, it will be SO7 and 8. It can be 1 out of 3 can be positive. And we found this assay to be very, very good. And assay less than 3 TCT of 30 was positive at SO6 in all 3 of the wells, and more than 30 was SO7 and 8. And in fact, we also found that the Sanger Institute were not able to sequence once we hit 7 and 8, corresponding to those city values. And we discovered very early on the N gene is more sensitive than the ORF1AB was more sensitive than the S gene. So that was a TAC-path assay in September 20. Again, we did the same thing. We had similar results. Whereas the new one, which is the LGC Endpoint PCR, the new name for that as of in the last few days is Ultra TX SARS-CoV-2 N1 N2 RPSA in September 2020. That one can go all the way down to SO8, or it's a clean sweep. It's the most sensitive assay. So this endpoint assay is more sensitive than TAC-path. So back to the TAC-path, we decreased our internal quality controls from 8 to 6 to 2. That was 1 positive and 1 negative control, leaving 94 wells behind. And over time, we have now introduced 2 positive controls from different manufacturers and 1 negative control. So then 93 wells are available. And we validated every TCAN, Kingfisher, and ABI 700 as they entered the service. Then we tracked the performance of every machine, every reagent for every shift. And internal quality assurance, we initially used split samples, and now since November 2020, what we have is we have a 96 well plate duplicated, coded, and retested, and that way we assess in every shift what is happening through the system on a daily basis. We had a lot of problems which we solved, and we improved the TAC-path assay, deletion of ethanol wash step. In fact, we suggested to the company that we can reduce the volume from 400 to 200 microliters. That they implemented worldwide after we suggested that. And typical, the SARS-CoV-2 RNA targets were very, very solid, less than 2% variation. And we also proved that if you keep this MS2 Forge outside for 2 hours, and that's based on 20,000 samples, it just goes off. And we looked at the manual resolve of plates as opposed to the automatic resolves. And those are the criteria we set. We keep varying that depending on the prevalence. So we looked at the problems. For example, on 30th of April, we had a problem of an issue with the contamination, and that happened, and that way we had a lot of inhibitions. And since then, it's been more stable. And this is a call between the automatic call and then the actual manual call, and we monitor that to make sure the more automatic calls we have, that means the smoother the assay is running, the process is running. The reason we say that is every time we find a problem, let's say you are testing 4,000 samples an hour. By the end of 5 hours, you're looking at 20,000 samples would have gone through the system before you actually identify that there is a problem in the system. So we have to do that. So for that, we have all this leverage earnings chart according to every machine, and every outlier is identified. And this is a master mix chart looking at the combination of master mix over time. In this, 900,000 PCRs are on this particular graph, and we monitor this. And here is a bad, this is a S-gene where you can see the variations, and here's a good where things are a lot more stable. And here is another one to show the master mix performance, which we looked at it monthly and a bi-monthly basis to see if there are any issues. So back to the LGC endpoint PCR, we designed it in such a way you have 384 wells, of which 12 wells are controls, of which 8 of them are positive controls, that is Accuplex positive controls, which are titrated against the Qinostics positive controls, right to the limit of detection, or say not too strong, not too weak. And that's how they are designed, and that's how we get the positives and the negatives. And then that's the RNSP, which is the cellular human genome cellular control. We obtained MHRA approval for this in December 2020. Moving on, we looked at contamination, because when you're testing at such large numbers, we are very, very conscious about the possibility of contamination. So we have ongoing prevalence-based adjustable positive prevalence check, enforces manual review if the number of positives increase dramatically. We look at patterns, pattern recognition. We looked at any array quadrant problem, because remember, when we array it, 96, 96, 96, 96 leads to this 384, and we know where each well has come from if there's a tracking. And this particular thing on the validation of the whole thing is going to be published in early hours of tomorrow morning on the gov.uk website. So we did the validation of the endpoint PCR with a real-time existing PCR tag path assay and about 39,000 samples, very high sensitivity, very high specificity. What I'm very pleased about is the near total concordance 0.94 Cohen's kappa, because we have to be careful about how we evaluate a test which is more sensitive with a test which is less sensitive, and that's why the Cohen's kappa is very, very important. So here's a summary. We talked about how the sample comes in, lysis, addition of magnetic beads, RNA extraction, and then the PCR agents, real-time endpoint on the left-hand side, analytical software reporting. And this is the actual sequence, how it happens. And I mentioned to you all the photos that you saw is a summary of everything. In the endpoint PCR, the first 4 steps are the same. And beyond Kingfisher, you have a rearray, then it goes into the Nexa, into the hydrocycler, into the array, and that's at the end of the reaction. We detect whether it's there or not. It goes into the Agentech and then back into the LIMS for the reports. Reporting of results. So within the Lighthouse laboratories, Milton Keynes, Glasgow, and Alderley Park use this particular assay, where 2 genes less than CT of 30 is a positive, and then we introduce the concept of positive or limit of detection, which is plot for abbreviation wise, and those are the various criteria for it. Basically, weak CT more than 30, that means it's plot. So we know I mentioned to you about the sensitivity, and we mentioned to you about the CT of more than 30. So the endpoint PCR here is a collaboration between LGC, NHS, DHSC, and UK Biocenter in Milton Keynes. The N1, N2 gene primers and probes as per CDC, RNSP as a human control, and superplex because both the N1 and the N2 probes have the same dye. And endpoint PCR because at the end of the cycles, where the fluorescence-based assessment, MHRA documentation I mentioned to you, and the contractual negotiations happened, and it's gone live now. So when we go through this, we see the positives and then you have the negatives. Right in between, you have the plots or the positive limit of detection. And then that was in the pilot. And when we looked at 39,000 or 40,000 reactions, we again had a clear delineation of the positives and the plots and the negatives. But look at the greens there in between. Those are the inconclusives, which is between the plots and the negatives. There is a band where we don't know what it means. So we have a clear algorithm. So let me explain to you here. The first die here looks at the plate reference dye, whether there has been any pipetting error. If it's less than 2000, that means then the entire result is void. There hasn't been anything that's been pipetted. If it is more than 2000, then we look at the RNSP. If that is more than 2000, that means there's enough human cells. Then we look at the FAM to see whether it's a positive, plot, or a void. That means it's in between that, inconclusive, and then negative. Well, majority of the results we expect it to be negatives. And however, if there is a problem with the RNSP, only the positive and the plot are relevant, whereas the remaining, the ones where they don't have fluorescence for the FAM are all void or inconclusive. Now, when we have all this data coming out of the labs, the ministers need to know what exactly happens. So this is what they see. This was developed by the Deloitte IT teams, which has a number of samples, number of positives, number of voids, and how the capacity of the lab is, how the turnaround team. I have blacked out or whitened out all these things, obviously because these are confidential figures. So, and this is what they get on a daily basis from every lab to look at the performance of the assay, and it's all built into the contract. It is fairly tight, and they monitor every up and down in every possible result or every possible issue in the lab is identified. And then over time, they get dashboards like this, how the laboratories are performing, including how the turnaround times, whether there is a problem. If there's a problem, usually you see an increased turnaround time. So, the staff, the people who come into the lab, this is how they are welcomed into the lab. It's all the social distancing. There is a thermometer to welcome them in, and then they register and they get in. And of course, we had the MACA, which is the military aid to civilian authorities. 20,000 of them were deployed in the beginning to help the lab up and running. So we needed people for shift pattern, which we got. We need 900 plus people. We got about 700 plus at the moment. We had all these various groups of people, IT, procurement, data analysts, etc. We have clinical scientists and BMS. In the beginning, we had a lot of university people coming in to help set up, and gradually they've been replaced by resident BMS and clinical scientists. And of course, we have had a lot of hard work by DHSC and NHS testing teams, the T&D teams. And the people actually working in the Milton Keynes, some of them don't go back home for weeks together. And they've done a lot of sacrifices working from 9 o'clock in the morning to 9 o'clock in the night. And that's something that we have to recognize. So staffing wise, to test 75,000 samples per day, we need about 78 people. To test 150,000 samples per day using Endpoint PCR, we need 80 people. That is, just 2 more people can test 150 to double the capacity. So together, we're going to have 2 lines in Milton Keynes, which is 150,000. Now, this component is being replicated in Leamington Spa to lead to a lab which is bigger than Milton Keynes that will go to 300,000 samples per day testing. So Milton Keynes will be the biggest lab in UK or probably in Europe for about few weeks before Leamington Spa takes off. So of course, we need a huge political will and for this to happen, and the ministers and the Prime Minister also has arrived and visited UK Biocenter. Lastly, milestones. These are the machines that you need for 35,000 samples a day, 75,000 samples a day is 15, and I mentioned to you about 225,000 samples a day. It's a mixture of both the TACPath and Endpoint PCR, and that's a list of machines. As you can see, just 2 lines of LGC, Nexus, heterocyclosin, and Araya can actually process 150,000 samples. So the ramping up happened very, very quickly. By 10th of July 2020, we had 35,000 samples processed. And this is an old slide just to highlight satellite labs, home, Oxford University trials, vaccine trials, mobile testing unit, regional testing sites, and ONS. These samples come into all these Lighthouse labs. There are more labs now in Loughborough, Newport, and Newcastle. And also there are surge labs, which I have not mentioned in this slide. And this was in summer where we had a lot of positives, and that number started coming down, and we all had holidays. And of course, things started going bad sometime in September, and by November, the numbers started increasing. And as you know, the peak was sometime in early January. So we have realized the importance of cloud, and that's going to go live on NHS Digital very, very soon. A lot of civil servants are working very, very hard to make this happen. We've identified a lot of manufacturer issues, and then all these things have had to systematically, we have troubleshooting teams. There's a worldwide shortage of TCAN tapes that's been sorted, and this is a very complex operation for NHS Digital and INPEX. There are something like 10 organizations which are involved every time a result goes out, and that's why we need to have patience to make it work, and we've had it. And of course, we discovered the S gene deletion in December 2020 in Milton Keynes, and that's what happened. Sometime here, way back in middle of November, you had an increased number of S gene deletions, and by January, you can see 98.99% of all the samples that we had were the deletion virus. And that's the last slide to show you. 3 gene positives were here, and that starts coming down. And then the light green was a S gene deletion, and that starts going up somewhere here. It is a meeting point, and this particular phenomenon is what is a new virus that we have. And lastly, in the last slide to show you, we reached a milestone of 8 million samples, 21st of January 2021, 4 days ago. That's why my title, Testing Bigly, 8 million and beyond. And I thank everybody within the DHSE who made this happen. A lot of support from everyone who's worked day and night, weekends, in the middle of the night, and the LGC team for working very hard to make this happen. Of course, the King's executive let me go and be seconded, and Viapath executive to just let me go away from King's. And all these people within the Milton Keynes laboratory who worked extremely hard, hundreds of volunteers, and of course the Deloitte team who were there originally, they're still there, a couple of them, and the Viapath team who came in to help us set up the Milton Keynes lab, and of course my fellow clinical advisors who keep me on my toes and keep me alert. So with that, I stop and I'll take any questions.
So thank you very much. That's an insight into a completely different kind of laboratory from the one that I'm sure most of the audience are familiar with. And it struck me as you were talking that you test more samples in one day than some labs will test in 1 year. And clearly there are completely different challenges. So that's fantastic to get that kind of insight. So there are already a number of questions, and somebody I saw also commented that this is a phenomenal achievement. So testing on the scale that you're doing, set up in the time frame that you did it, is indeed a hell of an achievement.
Yes, it is a teamwork. A lot of people have sacrificed. A lot of people who do night shifts have left their children and family behind in order to come and do the night shifts. A lot of sacrifices have happened. And one of the perspective is, in a lab, a standard virology lab, we get about 250,000 samples a year. So in 4 years, we probably get 1 million samples. So this is 8 million samples. That's equal to 32 years of experience. Of course, it's one test, one sample, all the caveats there. But that's the scale of operation. Yeah.
Yeah. So could we just take the whole process from patient through to result? Because you've described what happens in the lab. The samples are arriving from any patient who is symptomatic and wishes to have a test. Is that right?
At the moment, yes, because it's symptomatic only. And the asymptomatic testing as a policy from the government hasn't happened widely, purely because to do the asymptomatic testing, you have 65 million people in UK. So even if you test 1 million people a day, you're looking at 65 days before you come to the next person. And that's the reason why. And do we need so much of testing? So at the moment, it is symptomatic. I suggest also anyone who's, if there's a nidus or an outbreak in a region, and that's where probably this will be useful, especially with the second mega lab coming up.
Okay, and an issue that comes up in the press, but you can tell us how much of an issue it is the turnaround time. So how long do you think it takes from the sample being taken from the patient to you passing the result back?
Well, it's about, it varies. So if it's obviously if it's a home testing kit, it goes all the way to Randox in Belfast. And they're the ones testing for the whole of UK. And then it has to be basically flown over from all over UK to that place. In the past, we also used to do that. Then they found it's more efficient the way the packaging comes to open it in one place. So there is an inherent delay where someone comes and picks up and then couriers. That's a different thing. Whereas at the regional testing site, for example, they're all mapped to the local Lighthouse labs, and that mapping is done. It's done very dynamically at 8 o'clock, 9 o'clock in the morning. The Deloitte and the laboratory team, which Damon Dominica actually leads, basically look at where the capacity is, where the problems are. Let's say there's a power cut or a contamination issue in a lab, then the samples will be diverted to another lab which has got the capacity, and that happens around 8 o'clock, 9 o'clock in the morning, all the way to the next 24 hours. So from the moment the sample is taken from these regional testing sites, you're looking at anywhere from a couple of hours to 4 or 5 hours before it reaches. And once it reaches the lab, if everything were to work well, you're looking at the results coming out of the system within 6 to 7 hours. But then you'll always have, as I mentioned to you, if there is a problem, the problem happens 5 hours down the line. By that time, 20,000 samples would have gone through the system. So we need to put a stop to the conveyor belt and go back and start solving what exactly, and then start doing the actual experiments to identify where the problems are. And that's where the delays are. Then once the testing is done, from the time the test results are released back into the NPEX, it happens on an hourly basis. So there were times where 98, 99% of the results were going out within 24 hours from the once it enters the lab. And now they're looking at the picture, especially the promise is that the regional testing site is where you're likely to get the fastest turnaround time within 24 hours. The rest of them vary depending on how far they are from the Lighthouse labs. So every time there is a hiccup, obviously things get delayed. Yeah.
So where precisely do the results go?
Okay, that's a very good question. So the results go to something called NPEX, which is lies within NHS Digital. From there, it goes into the SGSS, that goes to the public health, and then the SNOMED, and then you have the GP system, that it also goes to the Department of Work and Pensions, because the positive people who are positive need to know about it. And if it's these are just some of the systems. And also, let's say there is no NHS number. If there is no NHS number on the sample when they actually register online, then you're looking at anywhere from 12 to 24-hour delay before the actual search identifies the name and date of birth, and then it goes to the corresponding team wherever it's supposed to be. If there is an NHS number on the where the register, it's actually faster. So I'm not an expert on this, but it is a fairly complex situation, and there are people who have solved problems systematically one by one over time.
But is it true to say that the results go back to the GP?
Well, that's a question that's been asked. That's been worked up. It is one of the things is, do all results should go back, or negatives and positives, or it should just be the positives? One of the things we discovered is, if every result were to go back to the GPs, it will overwhelm the GP systems. The servers will crash, and those are the kind of problems we're talking about when you're looking at the metadata like this. Things that we wouldn't even think about in NHS lab, where the workload is not that much compared to that. There are different type of problems that come out when you're talking about mega numbers.
Yeah. So we've had a question. Are you not also getting asymptomatic screens from care home residents and staff?
Yes, we do. We don't have any control over what comes, and whatever, if the local public health person or team decide that everybody in the care home need to be swabbed, that's fine. It comes to us. For us, a care home has 50 or 100 people or 200. It's a drop in the ocean for us. We can just do the testing. Yeah.
And you make a big point about the plod, and it's a very important one. So the question is, what does the clinician do with that kind of result? Where do you put?
Well, it used to be called various other things. In some labs, they call it positive or limit of detection. Some people call it low positive. Some people call it indeterminate. But this is an all or none reaction. So plod is positive, yes, but it's a limit of detection. It can happen in 3 different situations. Number 1, the swabbing is not vigorous, and so you not have enough cells. Number 2 is early in infection, where the next sample will clearly tell you it will be a positive. That means a plot should automatically generate a repeat sample. Yep. Number 3 is what we didn't expect very early on in infection, is where people who have had the virus and have recovered, they're shedding the virus or the RNA fragments for a while. And that varies from even healthy to immunosuppressed. It varies for a long time. And that's where all these things are coming in. The reason for defining this is, to call these as false positive is very wrong. Biologically, we are picking these things up. Because we did not have a classification before, we were putting them as false positive. That's a wrong attitude, wrong way to look at it. But the right way is to call it a positive limit of detection. Now, the clinical significance. You have one plot. The next sample, if it is negative, is clearly out. The patient is fine. But if the next sample is also plot, that means there's a continual residual RNA being shed. That means, again, it's not clinically significant. It's only when you have a plot followed by a positive result, then you start worrying what is happening.
Okay. So you're using highly sophisticated and very sensitive PCR assays, but we all know out there's a whole multiplicity of other technologies, and particularly the lateral flow. So you're asked a question about what is the advantage of a rapid antigen test, but I'd also be interested to know is, as these are being rolled out, is that having an impact on the numbers of samples being sent to you? Is LFA in any way replacing the proper approach of sending you PCR tests?
I wouldn't know because I will try to. Okay, I'm not an expert on using lateral flow devices in my own hospital. There are other virologists who use it. They're probably better off to answer the question on how it can be clinically used. My understanding of lateral flow devices, it should be used in the middle of a pandemic when there is a high prevalence. So the peak of the Gaussian curve, you pick out all your positives and the high level shedders in the middle of a pandemic. And that's when your positive predictive value is so high because the sensitivity of the assay is not that good. So that means all your negative results are not reliable. That's in a high prevalence setting. But using it in a low prevalence setting, let's say you want to test everybody going into the concert goers. Yes, you will pick up all the people who are likely to be shedding at that point of time. But that doesn't mean all your negatives are reliable. And I don't know whether the positives, there are some non-specific reaction in low prevalence population. If you look at WHO recommendation, they do not use it in a low prevalence setting. But if you look at the practical side of things, here are the lorry drivers who are about to cross the channel. Do you want to make them wait for 1 or 2 days before you get the PCR results? You want a quick and easy answer. Easy, yes, but whether it's accurate is a difficult thing. So that's where the lateral flow device is probably coming in. I'm yet to discover the full clinical impact of lateral flow devices. I don't know whether it will affect the incoming samples to our laboratory. One of the things is by having this massive capacity, we can potentially change the policy. If the government wants it, you could have it for asymptomatic testing.
Okay. Amrit Bindra has assured us that results are going out to primary care, but has also said some results are given as unknown. And we've also had another comment about sample results being sent out as unknown.
That will be the voids. I mean, the voids can be divided, or unknowns can be divided into two components. Number one are the sample voids, that is a sample that's come in unlabeled or crushed or completely smashed up sample where nothing is in it. You cannot retrieve, or a dual labeled ones, yeah, in which case you don't know the identity of it. That's your sample voids. The lab voids are primarily like inhibitions that you would get. In a mega lab situation, you cannot actually go back and retest, which you would do in a NHS laboratory. So how can you retest 60,000 samples if there is something were to happen? How can you retest 5,000 of them? So we still try to go back and retest. I can talk about retesting for a while. And these inhibitions are a catastrophic failure in a laboratory, which all these things are all will lead are the laboratory voids. So together they constitute the voids, which are the results coming out to the patient as unknowns, which means you have to send a second sample.
So another challenge is what's going to happen now that we're vaccinating. Do you foresee that this rollout will have a dramatic effect on the testing program?
Difficult to model, not a modeler. I don't know. That's a difficult thing to answer. I mean, hopefully, the vaccine is not designed to prevent mild or asymptomatic infection. It's designed to prevent severe infections. So having a highly sensitive test will still pick out all those RNA positive people out there in the community. So if the virus is circulating, you need to have the most sensitive assay, and that's what we have at the moment. I think it can be used as a tool post-vaccine surveillance. I don't know whether I answered the question, but approximately I think I answered the question.
Okay. Another topic is the emergence of variants. So your lab picked up the variants that were S gene negative. I mean, it's a sort of accident that you picked it up.
Well, it's full credit to the CEO, Tony Cox, who actually picked it up and asked me. I thought, something is okay. So wait, let's see the sequencing. And then, yeah, because they have close links with the Sanger Institute and the sequence, and they found that there is a deletion. So that's how we discovered the whole thing. And then that led to how the assay actually, which has an S gene component in it, can actually miss the S gene being amplified. That means you're relying on the remaining two genes. That's how we picked it up. Yeah. Uh, the TACPath assay is probably the only assay in the world which can pick up the S gene variant at the PCR stage. Everywhere else, either you need to have some other mutant mutation assay or sequencing of some sort. So we are the only ones. So yeah, it was discovered in a lab, but not many people give credit for it. I'm a bit sad about it, but that's life. Yeah.
So are you still using the TAPath? Somebody's asked.
Yes, as I mentioned to you, the TAC path will form the 75,000 one line, and the endpoint PCR will form the 150,000 the second line. So we'll still have two lines. So there is always a backup of one because backup. The important thing here is to remember there's a massive machinery, logistics, and IT that feeds this beast. If something were to go wrong, you need to have an alternate. That's why even the Nexar line, we make sure it's never a single machine or a single line. It's always in duplicate. And that's exactly what's going to happen in Leamington Spa. There'll be two separate Nexar lines.
Okay. So in terms of reassuring the audience that if another variant comes along, it will be identified. What is your link to Sanger? Are you sending every positive or every fifth positive?
There are two things. There are two separate ones. One is the in silico one. Now the TAC path, for example, we identified yes, but all assays that we have in the land, I think there will be the manufacturers will be forced to do an in silico analysis, whether they're primers and probes. At the moment, they're all secret. We don't know what they are. Okay, so that's on the commercial side of things. But if you remember the LGC, the endpoint PCR that we have, every time the Danish Mink strain happened or the new variant, so within 24 hours, the LGC team were able to prove to me their N1 primers and probes are picking up these things. There are nothing missed. So that should be the way the company should work, where they tell within 24 hours to 48 hours, hey, our PCRs are picking it up. So that's one aspect. The second aspect is every positive that we have, we send it, the extracts are sent away to Sanger Institute. They get all the data that we have. They have links to the NHS Digital data. They can link the patients of the location up, and they're able to generate all the things for whole genome sequencing. And they've been fantastic to have develop all the facilities that they have and automated. Yeah.
Okay, so I'm getting instructions here to wrap up, and I can see it's nearly 1:45. So the very last question is an open one. What is the greatest challenge that you're currently facing?
The greatest challenge I'm facing is probably people, getting the people, making sure people stay in their jobs, be it NHS or PHE or in the Lighthouse labs, getting trained, stay in the same job, because the technologies that we've introduced, this LGC endpoint PCR, is new. It's new for everyone. So we have to find a way logically, scientifically to implement this. And it is scary to see suddenly 384 plates coming up, of which 100 of them are positive. Do you really think it's a contamination? But right now, we are going through a high prevalence one. So we are discovering things on a daily basis. And the people, we are taking the people with us to discovering all these things. It's the open and frank discussions that we have, which has made the Milton Keynes the place it is. A very positive place to work with, and it's the people who made it. So the challenge is the people, and that I think probably the way we solve it, and they are good people.
Okay, thanks. There are one or two more questions, but I think we've run out of time, but it just shows you the interest in this topic. So really, thanks again for giving us a real insight into part of clinical virology, which was completely alien to me. It's fascinating to see what is going on, and very reassuring to hear the capacity and the skills and the capabilities that that we have through these Lighthouse labs. There is clearly more questions about the long-term plans for these Lighthouse labs and what role that will have and how that will affect the practice of clinical microbiology in the UK. But perhaps that's for another time.
We are ready for next pandemic. We'll be ready for anything that comes our way. That's the way we look at it. Yeah.
Lovely. Okay, so it just remains for me to thank everybody for attending. Thank you for the questions that kept piling in. I'm sorry if I didn't ask your particular question, but if you, we can probably have a look at those, and if you're keen, then email us and we'll respond. Next week, another key topic. They're all key topics at the moment, and that is vaccines. We have Professor Peter Openshaw from Imperial, who is going to come and talk, and then we'll have our usual 15 to 20 minutes where we can grill him. We all have questions about the vaccines, so I'm sure I'll see many of you here next week. Do remember to re-register for the meeting next week. That's it. It's been another fantastic evening. Many thanks to everyone, and stay safe, and I'll see you all next week. Bye for now.
Bye-bye.